Question 7. This question is about group 7 elements and their compounds. Chlorine is used to treat water even though it is toxic to humans. Okay? Give one reason why water is treated with chlorine. Explain why chlorine is added to water even though it is toxic. Give an equation for the reaction of chlorine with cold water, all AO1. Actually, maybe this one. Maybe not AO1. But the equation definitely is, and so is the reasoning. I'm pretty sure the reasoning as well. Well, we know chlorine kills microorganisms. That's why water is treated with chlorine, to make the water safe to drink. Kills microorganisms. Kill microorganisms. Explain why chlorine is added even though it's toxic. This is a pretty tricky question. And I'm saying, well, why is chlorine added even though it's toxic? Well, it's because it's only used in small quantities / low concentrations. That's why chlorine is added even though it's toxic. Only used in small quantities / low concentrations. And then the equation, chlorine with cold water plus H2O HCl. (7.2) 4 marks worth of equations where you have to, it's not memorizing equations, it's testing how well you do know the skill of giving half equations. So we know solid sodium iodide reacts with concentrated sulfuric acid from iodine and sulfur in a redox reaction. Okay, give a half equation to show the conversion of iodide ions to iodide ions. So I minus to I2. So we've got 2 here, so we need a 2 here, but now we've got 2 negative minus 2 charge here, so we need to add 2 negatively charged electrons here to balance the overall charge of negative 2. Give a half equation to show the conversion of sulfuric acid to sulfur. Sulfuric acid to sulfur. So we're not going to include negative charge SO4 2 minus H2SO4. That's not even sulfuric acid anyway. SO4 2 minus H2SO4 arrow to S. Okay? Yeah, because if it was, it says sulfuric ions with negative charge. It says sulfuric acid H2SO4 to sulfur, which is just S H2SO4. So we've got one sulfur here, one sulfur on the left hand side, one sulfur on the right side, so that's fine. What do we want to do now? Well, we've got 2 hydrogens here. We've got 4 oxygens here, so we need to add 4 H2O here. So we also have 4 oxygens, but now we've got 8 H pluses. So we need to add 6 H pluses to get 8 H pluses on the left hand side. And now we have, are the hydrogens balanced? Yes they are. Are the oxygens balanced? Yes they are. 4 and 4 on each side. 8 hydrogens each side. 1 sulfur on each side. Now the charge is balanced. No they aren't. Overall charge in here is 0. Nothing plus nothing charge. And then overall charge on the left hand side was 6 plus. So we need to add 6 negatively charged electrons to get an overall charge of 0. Then it says the overall equation. Well, what we want to do here is we want to times this equation 1 by 3 to get the same number of electrons here, so it cancels out, so we're left with, so if we times this whole equation by 3, 6i minus arrow 3i2 plus 6e minus, then add them together, so we've got 6i minus plus 6h plus plus H2SO4 arrow 3I2 plus S plus 4H12, and the 6 negatively charged electrons cancel out. Yeah, that's the whole point of timesing this equation by 3, is that because this 6 electrons on the left hand side of the second equation, 6 electrons on the right hand side of the first equation, and therefore they cancel out. Then the other sulfur containing reduction product. Half equation, no, it wants us to identify one other sulfur containing reduction product form and solid sodium iodide reacts with concentrated sulfuric acid. Solid sodium iodide reacts with concentrated sulfuric acid. It is H2S. Yeah. You need to know this equation as well, and what is formed as well is H2S, hydrogen sulfide. So yeah, H2S. And then it says sulfur nitrate is added to solution. Suggest why an axis is used. When a student completes an experiment to determine the percentage by mass of sodium chloride and mixture sodium chloride and sodium iodide. Well, an axis is going to be used to ensure that all the halide ions, aka the chloride ions and the iodide ions, are removed from the solution. So silver nitrate is added in excess. Just when excess is used, when it's added, to ensure all the halide ions are removed from the solution. 7.4. Calculate the amount of moles of silver iodide obtained. Well, the mass of silver iodide is 315 milligrams, so to convert into grams, it's divided by 1000. 0.315 grams, and therefore to convert into grams to milligrams, we times by 1000. So moles is going to be mass over mR, which gives us an equation. Therefore we get 0.315 divided by 234.8 and 1.34 times by 10 to the power minus 3 moles. 7.5. Calculate using the answer to question 7.4 the mass of sodium iodide in the mixture. Well, the mass of sodium iodide, well, moles is mass of mR, mass is going to be moles times by mR, and sodium iodide and silver iodide are both going to have a 1-to-1 molar ratio. And it also says using the answer to question 7.4, so we're going to use the answer 7.4, 1.34 times by 10 to the power minus 3 moles, 4 times by 10 to the power minus 3 times by the mR of sodium iodide, 149.9. Naught 0.201 grams. It's already given us the units, we don't need to include the units. That's fine. Mass is 1.24 times by 10 to the power minus 3 times by 149.9. Then it says 7.6. Calculate using the answer to question 7.5 the percentage by mass of sodium chloride in the reaction mixture. Using the answer to question 7.5. Well, 7.5 gave us a mass of sodium iodide. We want the percentage by mass of sodium chloride. Well, if we scroll up, we know that the mass of silver iodide, we know the 600 milligrams of this mixture dissolved in water to form a solution. So what we're going to do 600 minus 201, so we just convert the grams into milligrams, which will give me 399. milligrams. And now we want to find the percentage. Now this is the mass of sodium chloride. Therefore, to find the percentage by mass of sodium chloride is going to be 399 over total mass 600 times by 100. 399 over 600 times by 100. 66.5%. Don't forget the percent as well. And that is the end of question 7.